Hello everyone and welcome to another problem solving section, Special Maths Academy. And in today's video, we are going to cover a problem from the Senior First Round Maths Olympiad 2020. And that is the problem 3 of the exam. So the question goes like this. The AMGM inequality states that x squared plus y squared is at least 2xy for all real numbers x and y. So let A and B be real numbers. Which of the following may be greater than this? So these are the options. And if you notice, like the question started with this, so like this should be a hint or maybe an idea that we may use to solve this question. So the statement, the question that we are being asked, which of the following may be greater than this? So it means that what we are expected to do is to like try and show that 4 out of these 5 options are less than or equals to this expression given here. Then the remaining one that we can't show is less than or equals to this. That is the exact option they're asking us about. So that's why the word may is used. Sometimes it may be greater than this. Some other times this may be greater than that. But there's no like one constant direction like of the inequality. That's why the word may was used. So as usual, we have to check out the options and see what we can prove or what we can disprove. For this option A now, and yeah, this question started with the AMGM inequality. So that's what we're actually going to use to solve this. But we have to like find the correct way to apply because there are a lot of ways to apply AMGM here. Some of them may help us with the question. Some others may give us some other results, but are not going to be useful in solving this question. So that is like we have to actually try a lot of things out. And so by trial and error, I was able to find out that if you apply the AMGM in this form, so we're going to apply AMGM 4 times. So actually prove that this first option is at most this expression given here. So it means that if we can show that it's at most this, it means that is not the answer. So we're actually expecting to get like 4 of the options that are at most this. So by a lot of trial and error, I was able to like find out that applying AMGM to these 4 inequalities will be really helpful. There are a lot of ways to apply AMGM, like even I think like got stuck at some point, but yeah, after going through it and carefully, I was able to like get out all this. So if we apply AMGM to these 2 terms now, we are going to get that this is greater than or equals to 2 the square root of a raised power 8 times a raised power 14 because we're multiplying it b raised to power 4. So we're going to get that this is greater than or equals to 2 absolute value of a raised power 7b squared because square root of a number, we're not sure if it's positive on a number like that. Square root of any number is like absolute value of like because square root of a raised power 14b squared is absolute value of a raised power 7b squared. So but absolute value of any number is at least that number. So it means this is at least. And similarly, this is greater than or equals to 2 absolute value of a raised power 5b, which is at least this. And this is going to be greater than or equals to 2 absolute value of a raised to power 3 b raised power 5, which is at least a cube b5. And this is going to be greater than or equals to 2 absolute value of a raised to a times b raised power 4, which is at least 2a b raised power 4. So now when we add up all these 4 inequalities together, we're going to get that a raised power 8 occurs twice, a raised power 6 b raised power 4 also occurs twice, a squared b squared occurs twice, and b raised power 6 b raised power 6 also occurs twice. And on the right hand side, each of these terms have coefficient 2. So when you add up everything and divide both sides by 2, you then get that what we have in the question is at least option A. So it means that what we have in the question is greater than or equals to option A. So option A can never ever be greater than what we have in the question. So this is not the answer. This is not the answer. So now let's go to option B. Option B now, if you look carefully, option B and option A have some common terms. Like this is common to both of them, and this is common to both of them. So what the only difference is are these middle terms. But if we can notice carefully that like this middle term of option A, that is a raised to power 5b plus a cube b raised to power 5 is going to be at least 2 square root of a raised to power 8 b raised to power 6, that is equals to 2a4b cube, which is greater than equals to 2a4b cube. So it means that this middle terms in the first option is greater than equals to the middle term in the second option. So but now we have gotten that this the expression in our question is greater than or equals to a. And we just indirectly now got that a is greater than or equals to b. So definitely that chain of inequality should imply that what we have in our question is greater than or equals to b. So it implies that b is also not the answer. So now we'll go to option C. Well, after a lot of trial and errors on how we can apply the EMGM, I wasn't able to disprove the case for option C. So that was now what made me to start suspecting that option C may be the answer. In order to verify that option C is the answer, it's either I bring a counter example of that to show that for some values of A and B, option C is greater than the question, or I try to disprove the other options. So first of all, I'm actually going to do the two of them. But first of all, I'm going to disprove show that the other options are always less than or equals to what we have in the question. So now I'll go to option D. So how will I show that option D is at most this expression we have in the question? We're just going to apply EMGM in another way. There are a lot of ways to apply the EMGM. There are a lot of ways to apply the EMGM. So apply the EMGM in this way. A raised to power 8 plus a squared b squared is greater than or equals to 2 absolute value of this, which is greater than or equals to 2a5b. Actually, I can start keeping out this absolute value part because we've never ever used it. So I'll just start writing the exact stuff. And then similarly, a raised to power 8 plus b raised to power 6 is greater than or equals to what? 2a raised to power 4, b raised to power 3. And also, b raised to power 6 plus a squared b squared is greater than or equals to what? 2a b raised to power 4. Yeah. Then so we have all this now. So what else can we now do? We now apply this last EMGM. That's really confusing. I'm getting a bit confused here. Plus 2a cubed b5. Actually, this is meant to be a6 b4 greater than or equals to this. So this should be what? 2a4 b3. Yeah. So this is what we have. So now what we are going to do is we're going to, similarly as we did in the first, to disprove the first option, we are going to add all these 4 equations together. We want to add them together and collect like terms. I'll skip a lot of steps here. We have that 2a raised to power 8. A raised to power 8 occurs twice. Plus 2ab squared plus 2a6b4 plus 2b6 greater than or equals to 2a5b plus 4a4b cubed plus 2a cubed b5. So now, yeah, this is twice what we have in the question, and 2 divides all the coefficients in this question. So we can just clean out all the 2's now. And we'll be left with a6 plus, just clean out the 2's, So almost every coefficient we clear out except this one here. I just replace it 2. So, and this is actually like this last inequality got here shows that the expression we have in the question is greater than option D, because what's on the right hand side now is option D, as you can see. So it shows that option D is not also the answer. And option E now, if you look at option D closely and option E, like 2A4 is common to both of them. And also because a raised power 5b plus a cube b5 is greater than or equals to 2a4b cube. So adding 2a4b cube to both sides, what are we going to get? We're going to get that this is greater than or equals to 4a4b cube. So we got that option D is greater than option E, and we got that the question, let's just write to Q is greater than or equal option D. So what does it imply? It implies that the question is greater than or equal option E. So we don't even have to like check it directly. We can also check it directly, but it's not as fast as how we did it now. So I've now shown that all the options, excluding option C, is wrong. So now from here, we can conclude that option C is the correct answer. But as I say, I'm going to like do 2 ways. I'm going to like find an example where like find an example of some values of A and B such that option C will become greater than what we have in the question. So it was really difficult to find a value, but first of all, like the easiest way I could like try to find the value was when I made A to be equals to B. Because we know that if you put A equals to B, if you put A equals to B, each of all these 4 options will be 4, 4, 4, 4, 4. And also this will also be 4. So in order to like try to compare this with option C, I put A equals to B. Remember, I didn't like set A yet, but I just put A equals to B. Because I was trying to like find an example under that subcase, like when A is equals to B, when we get that option C is at least option. When we get that option C is greater than option, and then the expression given to us in the question. So when we put A equals B, what does option C become? It becomes A raised power 9 plus A raised power 6 plus A raised power 8 plus A raised power 7. And what does the expression in the question, what does it become? It becomes A raised power 8 plus A raised power 4 plus A raised power 10 plus A raised power 6. So this, inequality, you can like start from both ways, like you can start from front or back. So like this is greater than this if and only if. So what I'm now going to is like if we reach like an ending where we can find the value of A that that inequality is true, like when we keep on simplifying this, we can always like start from the bottom part and go up to like get that actually there should be some values of A that makes option C to be greater than the question, now the expression given to us in the question. So that's why I'll start the inequality like this, and I'll be using this if and only if sign. So we can see that some things are common, like A6 is common to both sides and A raised power 8 is common to both sides. And so we have that A raised power 9 plus A raised power 7, that this question, option C is greater than what was given to us in the question, if and only if this is true. So from here now, we can divide both sides by A4. But because A, like 4 is an even number, A raised power 4 is at least 0. So the sign of the inequality doesn't change. And generally, like none of these A should be 0. If not, okay, let me specify it here. A should not be 0, not equals to 0. So we are free to divide by 4, and so it becomes strictly greater than 0. We have no problems with it being undefined. So when divide both sides by A raised power 4, get that this is true if and only if this is true. We actually need strictly greater than 1 plus A raised power 6. Then if you notice, when A is equals to 1, both sides are equal. So like try to factor out A equals to 1, A minus 1 out to see what we can get. So I'll carry everything this side. A6 minus A5 minus A cube minus 1. So I'll try and factor out A minus 1. All these steps I'm doing just like try to find an example of A and B such that option C will be greater than this. So that's why all the steps, that's why I'm carrying out all these steps. It's not really necessary for the question because this is an object question. We can conclude that the answer is already C. So we have that this is true if and only if this is true. A plus 1, difference of 2 cubes. That is if and only if 0 So now, let's now say suppose we're supposing that A is greater than 1. Like we're reducing and reducing the subsets we're dealing with. So because I want to divide both sides by A minus 1, but I don't like the signs to start messing up. So that's why I'm supposing that A is greater than 1. I'll still add it here. So I say we can like use the previous values here to like even start setting these initial values from the very beginning. So suppose A is greater than 1. If A is greater than 1, we can divide both sides by this. So there will be no problem. Signs of the inequality won't change. So this is going to be so now this is what we have. So if we can find the value of A greater than 1 that satisfies this inequality, then that same value of A will satisfy that this option C is greater than this, what we have in the question. So the value of A I could think of was 1.1. Any value very close to 1 will work because remember, I can't make a value less than 1. If not, we contradict this last condition added there. So we'll just like have to choose value very close to 1. Because if you remember, when we put A equals to B equals to 1, like both sides were equal. So just a little shift on one side will make one of them to greater than the other. Just that we're not yet sure. But now that we have seen this, you see that a little shift of like when you shift it like slightly above 1, and maybe 1.1 or 1.2, it will still work. But if you now start making 2, like from 2 up, 32, this function grows very fast, much faster than this other 2. So I was like actually try and make it close to 1. So that's why I thought of 1.1. So yeah, so I claim that A equals to 1.1. We make this polynomial here to be less than 0. So 1.1 raised to power 5 can be found. But we know that like from the Pascal triangle, if you remember, like 1.1, like the fourth line is 1. This is 1.1 raised power 3 or something, or 11 raised power 3. They're all the same. They all like have the same structure. So this is like 11 raised power 4. I believe I've seen this before. I've heard of this before. So to find 1.1 raised power 5, we just have to like do something like this: 14641, 14641, 150, 161. So just definitely the point has to be here. So 1.1 raised power 4 is this. 1.1 raised power 5 is this. So this is less than 2. Then definitely 1.1 squared, we know is 1.2. And like, so definitely like a 1.61051 minus 1.21 minus 1.1 minus 1. No, clearly this is greater than 3. This is less than 1.61051 minus 3, which is definitely less than 0. Yeah. So as we have shown, like this is actually less than 0, and this satisfies our inequality here. So x equals A equals to B equals to 1.1 is a counter example. So like, and it shows that C is greater than this. But for some other values, like this is actually greater than this. For example, now when A is equals to 2 and B is equals to 1, then this option here, like what we have in our question, greater than option C. I just leave it to the reader to check that one out. So it shows that sometimes this is greater than this, some other times this is greater than this. That's why the word may is used. It's not like always constant. So this is how to solve the question. I'll see you some other time.